Hello guys, welcome back once again, and today we are continuing our access control list that we also call in the short form as ACL. Okay, so in the previous session we discussed about the standard ACL, and today we are going to look on the extended ACL. So extended ACL is just a little, we can say, advanced version of the standard ACL, and there are more flexibility or the more features to block the traffic based on the rules, that is permit or deny. Okay, so let's just quickly jump to our control list that is extended. Okay, so yep, this is just an example. I think we have seen that one. If not, then we will see once again, not a problem with that one. So extended control list, the syntax for this is like access list number, and this is a very important part. Access list number, if you take the number from 0 to 99, that is for the standard one. So you have to take care while choosing the number, right? So I will show you, not a problem. And after that one, you have to give a statement permit or deny, and then we can set the protocol, that on which protocol you want to permit or deny, right? And then we just set the source, right? After that, when we are putting the source, right, then we are having the source mask, from which source it is the traffic is being originated. Then we put the destination address, and whatever is the destination mask of that destination address, and then we enter it, right? So let's just understand what actually they are. So the first, let me clear it first, or let me take some other color. I think that will be a better idea, because it's red is already here in the slide, right? So green. Okay, let me take this color. That should be okay. Just a moment. Yep, perfect. So the first term, that is access list number, right? So access list number is basically we choose between 100 to 199, right? You remember, from 0 to 99 is for the standard access list, and from 100 to 199, if you take that one, that comes as extended list. Or else you can also give any name in place of the number, then also it will be considered as an extended access list. After that one, we can just give a permit or deny. Permit or deny means either you want to permit that source or destination address, or you want to deny it. So if you permit it, then it will be allowed. If you deny it, then obviously that will be blocked. After that one, we can give that protocol number, right? So protocol number, basically we can have that IP, TCP, UDP, or ICMP. So every protocol is having some specific number, so you can choose accordingly, and you can permit or deny based on the protocol numbers. It's like the segregating the traffic based on the protocols as well. So it means that sometimes you need that you allow only TCP traffic, right? So you can just permit TCP and deny remaining, right? So it's by default, if you permit TCP, remaining all will be denied. And if you just deny if you permit all and deny TCP only, so you can just write in a statement permit TCP. Now if you want to first you have to deny TCP, right? You want to block TCP only, so you will deny TCP, and then you will remaining permit all, right? So what will happen, first it will hit that rule, it will deny TCP. If it is not TCP, it will go to the permit all. So it like sequential, as we having on the standard one, right? Always whenever you having the different rules, if the first rule is hit, the ACL is not going to check the other rules. It goes with the first rule only. Then we are having the source mask and destination mask. So that's as usual, wildcard mask or source address, that's not a problem. Operator and operand, that's very important. So there are basically there are some things like less than, right? So then in less than is like short form of LT. GT is greater than, EQ is equal, and NEQ is not equal. So this is basically used for the port numbers, right? Sometimes you need you are having the specific ports like 79, 92. So then in that case you can just specifically put that block all the traffic which is having greater than 79. So all the ports number which are greater than 79 will be blocked, or you can just set the rule greater than 79 allow, or sorry, permit. Right here we are having the words as permit and deny rather than the allow. So based on that one we can use it. Basically normally what we do, we use most of the time equal, because we don't want to specifically block all of them. We just put the mention that if you want to a specific port number, like if you want to block HTTP traffic port number 80, so what you will do, you will put equal 80, so that only HTTP traffic will be blocked. If you want to block any of the other traffic, you will just equal any of the other, like if you want to block SNMP, so you will put SNMP is I think 161, I'm not sure exactly. I think SMTP is 25, SNMP is 161. So based on that one, whichever the port number you want, you can block it, right? Established allows TCP traffic to pass if the packet uses an established connection, for example, has ACK bits set, right? So ACK, we are having the TCP handshake, and in the TCP header there are flags. So if their acknowledgement bit is set as 1, that's what it's talking about. If you don't know the TCP flags and all, you can just watch my previous videos, it may help you. Okay guys, anyways, let's move further. So this is it. That's what I was talking about, this extended IP that is having the range of 100 to 199, and this one is standard 1 to 99. Perfect. So extended ACLs are used more often than standard ACLs because they provide greater range of control, right? Because if you talk about the standard ACL, then you can permit or deny based on the source address only. So you have just one option. But what if you, it's like let me give you an example too for the better understanding. Source address means that you can block or allow that specific user only. But what if you want to allow any user to Google, but you want to block him for the Facebook, right? Then what you will do, you will just block based on the target address that you will specific, you will allow for the or the permit for the Google IP address, and you will deny for the Facebook IP address. I'm just giving a random example, don't take it too serious. Just for your understanding, I'm giving this example that destination address sometimes you need it to allow or block the traffic, that is permit or deny the traffic. So that is having the better control of the traffic, that is the extended access list. And even port numbers, right? HTTP, which port number it is, or we can say FTP traffic, which type of traffic it is. So based on that one also you can block the traffic as. So that's the another part that I think we having greater flexibility, extra this one, and protocol type. This is it here. Let's check one by one, that will be better. Extended ACLs check the source and destination address packet addresses, as well as being able to check for protocols and port numbers. So that's how it is. I was talking about the port numbers. I was discussing about you port protocol number, but that's actually port numbers. This HTTP port number is this, and protocol number we talk about that TCP is protocol, right? So that is the TCP protocol number. So let me not right now. I will show you later on. So this gives greater flexibility to describe what ACL will check and all. So that's it. There's not much difference from the standard and extended access list. Just this is one difference it is. So there is, oh sorry, I'm feeling sleepy. Actually, this complete day work for office, then it comes to for the recording. So obviously you feel sleepy, you're too much tired. So that's how it is. Not to worry, we will have to learn something, right? So I have taken one example here, and it is saying that our task is, what if we wanted router A to permit only engineering workstation 172.16.50.2 to be able to access the web server in the administrative network with IP address 172.16.10.2 and port address 80 and all other traffic denied. So I will take this network with the IP. So this is server address 172.16.10.2. So rather than this, I will take a Google server 8.8.8. Okay, and then I will just configure that in packet tracer. What I will do, I will just take any of the workstation and I'll allow that one only to permit to reach the web server, and remaining all will be blocked. So if it go deeper in that one, what if router A permit only the engineering workstation, this one, to be access the web server, right? So what is saying, router A to permit. So we have to take care that this ACL will be deployed on the router A interface towards the web server, not on this. If you apply on this one, right, then what is happening is checking everything from here. But this is the job of router A, that which is checking that is it router A or someone else. If it is router A, then I have to allow the traffic. If anyone else, then block it, right? If you put it here, then what will be happening, it's just not having the better control. All other traffics might come here, right? So if we deploy it here, so in that case, all that other workstation like this one or that one, that will be coming here, that will be just denied, that will not be accessible. And if this only comes here, that will be easily accessing the web server. So I will just configure that one in the packet tracer. So let me check the some more examples, what else we are having. Placing ACL. Yeah, this is a very important thing. Haha. So this is the thing I was talking about, that where where I should put the access control list on which interface. So they are having some general rules. There's not a perfect rule, or we can say that is the definite rule. They are just thumb rule that you should follow, or you can easily do the things with these rules. So the rule says the standard ACLs do not specify the destination addresses, so they should be placed as close to the destination as possible. Okay, so standard ACL, they are saying that they should be near to the destination, while extended ACL as close as possible to the source of the traffic denied, right? Where you have to deny the traffic, there you will put the extended ACL. So if you do not understand, not to worry too much, this is not so important. Finally, what you have to do, you have to configure an ACL by yourself, and you have to take decisions that where you can put it, and how effective that ACL is on which interface. So basically this is we can say reasoning, or we can say, yeah, it's like type of reasoning, that how effectively you can think of and how creative you are. So this is like how smart you are putting the things in place, and allow or deny the traffic based on the different rules. So it's just on you, but these are the thumb rules. If you keep in mind, things go very easy. If you do not keep in mind, just not to worry, they are just foolish things. You have to just use your own mind where to deploy your access control list and how you can block the traffic. You can it's like you are going to be a security engineer, security administrator in your network. You are responsible that unnecessary people or unwanted people or the bad people may not enter your network, or may not enter your desired web server, or which is very critical, right? So the same job is being done by the firewalls, right? This access control list, they are easily deployed in the firewalls. And why we have given this job to the firewall? Because firewall are specific for this, and they do not have other jobs of routing. they just are very much responsible just for allow or deny the traffic, because this is a very hectic job of, or we can say that a processor taking job. We have to check the traffic, that how it is good or bad. We have to take decisions based on that one. So that's why we have just designed one equipment specific for this permit or deny the things. So that is being done by the firewall. So we have two options: either we can configure it in the routers. So if the access is small, that works very fine, but if you deploy very large access control list in the routers, they may go slow or the latency may be high, right? So it's better way to use firewalls. But if you have a very small network, not very small, if you have small networks, and so you don't have to buy firewalls for that one, you can just deploy access control list and they will do the same thing. Not the perfect same thing, because right now they are having so different high-tech firewalls, like they are providing you security at the application layer as well. We also call it as next generation firewalls. So we do not talk about that one. If you talk about simple layer 3 firewalls or layer 4 firewalls, because we are also talking about the port numbers as well. So that's what the same thing we can achieve with the routers as well. Okay guys, so you can read all the things whatever it is written over. That's the same thing what I have just discussed with you. Okay, so let's move to next slide. So another thing I just want to add it here: ISP use ACL to deny RFC 198 address into their network, as these are non-routable internet addresses. You might have been gone through the concept of the public and private IP addresses, right? Public IP and private IP, right? So that's how they are actually. So you might be aware that public IP are used in the ISP network, right? While the private IP addresses, they are just used in the our entire, not entire, in fact, our private network. Like if we are having some LAN, inside that one we can use multiple private IP addresses. So these private IP addresses, if you route in the normal environment, ISP environment, what happens that let's suppose this is our ISP, right? There are a lot of AS connected with each other. You are using any private IP addresses like 192.168.1.1, and the same IP address is somewhere else, any other company that is also using that 192.168.1.1.1, right? So now it is an IP conflict that they are connected to this any company, that is, let's company A, that is having their IP address of 192.168.1.1, and there's a company B that is also using that same IP address, right? So that's not possible in the real environment. So that's why we have a concept of buying the public IP address, and we pay for that public IP, and these private IP addresses can be used just internally in any of the one company, not outside of that company. So if we come to our global environment and the ISP environment, we have to use our public IP addresses. What if that you just send that this is my IP address, and you advertise that IP address to the ISP environment? Obviously that is going to be create a problem, and that may conflict with other IP addresses. So for that purpose, what they do, ISP do what they do, they just create an ACL, access control list, on the interface which is connected towards your enterprise or your company, and they block the private IP addresses. Whatever the private IP address range is there, they are going to block it. Even if you try to send traffic from that private IP address, it will be discarded or blocked by the ISP. So this is just common use or the simple use of the access control list. So that's what they have configured it here. Access list 111 deny 0 any log. 127.0.0 is an private IP range, so that's also denied. So it's like that, they deny all the you see that 192.168, after that all range is our up to here, that is a private IP, so they have denied that. Whatever the private IP is there in the ISP environment, whenever the ISP is giving you a connection, they are going to deny the traffic initiated from you. So that's it from this ACL. I will just want to switch to our lab. Let's configure it in the Cisco packet tracer, and then let's see what happens. Okay, how to configure this extended control list. Let's just have a look. I have taken the same lab what we have done for the standard ACL. What I have done actually, just let me open the pen. I have added this one server here, right? This is, you might have seen. So this is a server, and this one I have given an IP address of 8.8.8, and I will try to configure, not in fact configure, this is already configured with the IP address of 8.8, but I will try to do the things according to this server. I will configure the traffic for this any of the IP address, and I will try to block this host computer, that PC5 172.16.50.5, to access the web server. Or in fact we can take the same example what we have just discussed in the slides, that I will permit only, not, I think this is quite near, let me permit only this one, right? I think that will make a better example. Let me allow only this computer to access this web server here, and nobody else can access the web server, and that is IP address 8.8.8.8, right? So what we will do, we will create an ACL on this router. I will allow a rule on this interface, and I will apply on this interface. I will check the traffic which is going out on this interface. So if it is going on that interface, I will permit only this host and deny for all. So obviously I will just allow it, permitted this IP address, and remaining other by default rule, that is the implicit deny. So all the traffic will be denied and all the host cannot access the or the ping 8.8.8 server. So let's do it quickly. So I'm going to open this router CLI, that's okay. Oh, it's full screen. Okay, oh, here is good. Enable config T, and this time I will do this via extended ACL. Okay, so let me put it this side. Yeah, so IP access list, and I can put the question mark, and it is showing that you wanted extended or standard, right? So this time I'm going to use an extended. Then you can put the question mark, and obviously you are seeing the numbers as from 100 to 199, right? Because extended are having the numbers from 100 to 199 only. So you can give the name as well. So either you can give the number here like we did it for the standard, we given the number 10, you can give here number 110, rather than I'm interested very much to give it a name. So I will just block PC1, block PC1. So this is the name of my we can say access list, right? Oh, let me put it here, block PC. No, I will not going to block it, I allow it, right? So permit PC1, okay, and then I can put the question mark here, and there's nothing like that. So I can just entered inside the access control list. So this I have created PER PC1, and now I am going to put the rules. So if I put the question mark here, I can see the deny, permit, remarks, and there are a lot of things. So what I'm going to do, I'm going to permit, and I can put the question mark here. It is showing that what you want to permit, right? So you want to permit any specific protocol, GRE, ICMP, or IP. IP means any internet protocol. So what I'm going to allow, I'm going to allow any internet protocol rather than being a specific. I'm going to allow IP, means all the protocols will be allowed. And if I put question mark once again, now it is asking that source address, from which source you want to allow. So I want to allow 172.16.10.2, so I will just simply put it 172.16.10.2, right? If I put question mark once again, it is showing saying as a wildcard mask. So I have taken it as a class C address, so I'm going to put it 0.0.255. Perfect. And now if I put question mark here, now it is saying destination address, and this destination address is a new thing here in the extended list, and it was not in the standard one. So this time I'm going to allow any, right? You have put the question mark here, so there are options. You want be specific destination address or any or host. So this time I'm going to put it any, that any destination address you will be allowed, right? And if I put the question mark this time, it is going to that DSCP match packets with the given DSCP value, precedence match packets with the given precedence value. I don't care at all, so I just simply put it enter. I don't want to be specific on this DSCP and precedence. So this is just I have given one statement that permit IP address 172.16.10.2, which is this PC1, and I have given the wildcard mask and to any of the destination address, and that will be allowed, right? So if I put it enter here, and what I have to do now, I have to just apply this ACL to this interface, and that's that's going outside of this router. So I'm going to interface G0/0/1, and then I'm going to put it IP access group, name it was PC1. Perfect. And then I have to put it out, right? So I'm going to put it outbound traffic. Perfect. So in fact I should show that earlier it was pinging. That would have been better example. So let me put it no first time, right? So let it no, I'm not applying accesses now, and let me ping it if I'm able to ping it or not. Desktop command prompt, and let me try to ping it 8.8.8.8. So let's see if I'm able to ping it or not. Request timed out, and yes, I can reach this 8.8.8, right? And remaining because our job is to block other, right? This will also be allowed. So let me ping from PC2 ping 8.8.8.8. This is the same thing. We have configured the IP interfaces OSPF routing for this connectivity. So right now from all the computers, this 8.8.8 is reachable. If I ping from here as well, 8.8.8.8, if I check it from every computer, it is reachable. We are having very good connectivity. Now I'm going to apply the ACL on the interface. So this time I put it here, IP access group PRPC1 means that permit PC1 outside only. So now let me check it for PC1 first. So PC1 is perfect, very fine, it's working. And if I check it here, and it's also allowed for this, so it should not allow for this one. So I think I have to check my access list. Let me modify it once again, because it is allow, let me check from other one if it allow from this one or not. So from it is not allowed, right? So okay, that's just one problem here. What we did actually, if you just focus on here, I permitted this 172.16.10.2, and I have given the wildcard mask as 0.0.2.55. It means that I have allowed the whole subnet, right? Whole subnet is allowed on this one, right? So that's why what is happening, this can also ping, this can also ping, but all others, means all the computers on this subnet, that is in fact network 172.16.10. something, whatever it will be, they can reach the server, while all other cannot. So that's being specific, but it is a good learning for you. Sometimes we do such type of mistakes and we learn from that. Now it's a very tricky question for you, that all hosts are allowed, right? All hosts on this network are allowed, but still our task is the same, and we have to allow only this computer and we have to block all other. So what else we can do? What else we can do for this? Do you have any clue? No? Thinking? Okay, not a problem. If you got it, it's okay. If not, let me tell you. So for that one, what we are going to do, we are just going to check the access list first, that what is in the access list. Show IP access list. So we are having one access list, that is a PER PC1 on this computer, and it is having the statement 10 permit IP, and this sequence number is 10, and it is saying that permit IP address, this one, not this specific IP address, it is saying that whole network is allowed. And after that one, what if we want to block it, then obviously we have to deny this statement, or else what we can do, we can just delete this statement and add be specific for the host. So rather than that, I want to do one more exercise. Let it be, you got the point. If you want to allow that only computer, what you can do, you can just put the specific IP address of that host and give the wildcard mask 0.0.0.0. Let me do it for you. It will be difficult to understand just with the words. Let me go to IP access list PER PC1, right? Access list PER invalid input name. What happened? Just okay, extended. And then we are having the PER PC1, perfect. And if I put question mark here, it is showing the sequence number first. So what we are going to do, we are going to use the same sequence number as 10, okay, and then I am putting the question mark. Now it is saying the permit or deny. So I am going to permit that IP address 172.16.10.2 and IP, because I want to allow all the IP addresses, and then I'm putting, I think, oh, I just missed 0.0.0, and then I'm going to put IP. There's some problem with this. It's still okay. Permit IP, it should be here. Sometimes we don't put the question mark, we forget it. So now I'm going to allow 172.16.10.2. being specific, I'm going to put 0.0.0, that I want only this IP address allowed. This last time what we did, we put 0 here, if you remember. Right, 172.16.10.0. when we put the 0 at the last, it means that whole subnetwork or a whole network was allowed on that case. So this time we are being specific and we are allowing any destination address, putting the question marks. Yeah, that does not matter. So duplicate sequence number, okay. So what else we can do, we can first delete that sequence number, right? So no permit IP 172.16.10.0.0.0.0.255 any, right? So now we don't have any IP access list extended IP PIR, and there's no statement inside that access list, right? So now I'm going to create and access list, and that will come. And that sequence number that came as a 10, right? But we can set any of the sequence number from that value. If I put question mark here, we can put any sequence number between from 1 to this value. So this time I'm going to put sequence number as a 1. Okay, 1 permit and IP 172.16.10.2 and 0.0.0.0 any, and that's it, I think. Yep. So now if we check our access list, then we are having just one statement, and that is already applied on that interface. So obviously only this interface I host PC1 can access that 8.8.8. Now PC2 will not be able to access our web server. So web server is just only allowed with this only. So now if you by chance there is some other manager come and he says that I want to allow this host as well, right? This time 50.55 cannot access the internet. So what we are going to do, we are going to modify this access list, and we will add one more statement like permit IP host 172.16 dot, what is the IP address, 50.2, right? 50.5 50.5 and any, right? Yeah. So we are having the two statements now. Let's show it, let's see it. So one permit IP host this one and this one. So now let's ping from here, and now we can ping it. And if you check the IP access list, you can also see the matches as well, right? So matches is means that how many hits we are having on that case. So 4 hits on that first statement and the 4 hits on the second statement. If you ping once again, so you can just see once again that how many hits you are having. If they are just double. If you want to deny any of the traffic being specific, although this traffic is already denied 8.8.8, but still you can put in a statement being specific for that. Let's deny that PC6 that it cannot access, right? So let me give in a statement deny host deny IP host 172.16.50.6, right? So if I do it this time, so what will going to happen, it will hit that rule, whatever the statement it is going to have in, right? Last time earlier we pinging, but we are not getting any count for that one. But if we put this statement, then we will get the count of that one. And I think we have not given 0.0.0. Let me give that as well. It might create a problem sometime. And earlier it was not created problem, but is now creating. Sometimes it's just strange. What is this? Destination address. I think it's already taken that this is an why it's not asking the wildcard mask. Anyways, it's not asking, so why to unnecessarily give it? We just have two statements, and yeah. Access list, we are having the statement 21 deny IP host 172.16.50.6, and there's no match for that one. But if I try to ping it from here now we'll get a hit on that rule, and it will say that it has been hit 4 times. You see, because it is denying the traffic from this rule, and whenever the traffic is being denied from the implicit deny rule, then there's no hit for that. So that's how the IP access control list are, and you can just play with it, create the specific rules, apply on the different of the things, and just practice it, because this is the thing which is totally depend on your creativity, how creative you are, how good thinking you are having, make good case, take a real life scenario, do practice by yourself. And if you face any issue, just reach me from any of the platforms. You can follow me on Instagram, Facebook, or you can just write on the comment section of our YouTube. I will also reply over there, right? And you can just directly send me message on as well on this Instagram or Facebook pages. Fine. So if you are new here and you don't know my Facebook page, let me show you if I have it or not. No, I don't have. So I have it. Sorry, guys. So let me put it here. Yep. So you can follow me in Instagram with the name Sir Anuj Shukla, SHUKLA. Perfect. You can go with that one, or I can type it here. It will be easy for you. I can write a command like Sir Anuj Shukla. Right. This is my Instagram ID. You can use that one. Or in the Facebook group is there. Name is I think CCNA VIP. I have forgot the name as well. Yeah, CCNA VIP is there. There's a group like, so you can go facebook.com groups/CCNA VIP and you will redirect it to my Facebook group. You can, oh, G is not here, I think. Why it is not? Oh, IP. I think it's just, let me, yeah, now it's okay. Facebook.com groups CCNA VIP. So this is the group, Facebook group, and this is my Instagram. You can follow any of them based on the request. Anyways, if you don't have any doubt, you don't need to reach me. You can just watch the videos and go ahead, because I keep on uploading new videos. Okay, guys. So it's my dinner time. I'm going to have my dinner. See you on next video. Next time I'm going to, what I have my plan, we will look on the network address translation, NAT. We will do NAT in the next video. Okay, till that, bye bye. See you soon in the next video, guys. Bye.